Hello everyone, in this video we're going to solve 2025 AP Calculus BC free response question 5. Alright, let the function y equals fs be the particular solution to the differential equation dy over ds equals 3 minus s times y squared with initial condition f of 1 equals -1. Now question A, find the second derivative of f at the point 1 minus 1, right? Show the work that leads to your answer. Alright, so question A is actually, this is the first derivative, right? Now, second derivative, which means we take the derivative of this one more time, right? So we have d over ds of dy over ds, right? We're going to use the chain rules, right? U times v is going to be u prime v plus v prime u, right? So it's going to be derivative of this one, 3 minus s, could be -1, right? Times y squared plus 3 minus s times 2y dy over ds, right? Now we need to calculate dy over ds, right? So we have dy over ds when s equals 1, y equals -1. We substitute 1, -1 into this equation right here to solve for dy ds, right? So it could be 3 minus 1 times -1 square, right? So it could be 2. So we have -1 times y squared, which means -1 square plus 3 minus 1 times 2y, which means 2 times -1, right? Times dy over ds, which means 2. Right? Simplify this one, is going to be -1 plus this one is equal to, this one equal to, so 4 times -2 is going to be -8. So the answer is -9, right? Now let's move on to question B. Write the second degree Taylor polynomial for f about s equals 1. Now we know that the Taylor polynomial expansion is given by the formula Pn of s equals f of c plus f prime of c times s minus c power of 1 over 1 factorial plus f double prime of c times s minus c square over 2 factorial plus etc. plus f and derivative of c s minus c power of n over n factorial, right? Where s equals c is the center. Now in this situation c equals 1 because s equals 1, right? Now we only need to write the second degree Taylor polynomial. So we have p2 of s equals f of c, which means f of 1, right? Plus f prime of 1 times s minus 1 over 1 factorial plus f double prime of 1 times s minus 1 square over 2 factorial, right? Alright, so f of 1 is given right here, -1, right? So we have -1 plus f prime of 1, we're going to use this one right here. We substitute s equal 1, y equal -1 into this one, right? We got it right here, it's equal to right here, right? So it could be 2 times s minus 1 divided by 1 factorial equals 1, right? Plus f double prime of 1, we got it right here, equals -9, right? So it could be -9 over 2 factorial equals 2, right? Times s minus 1 square, right? And this is the answer. Alright, now let's move on to question C. The second degree Taylor polynomial for f about s equals 1 is used to approximate f of 1.1. Given that the absolute value of f triple prime of s less than or equal to 60 for all s in the interval 1 to 1.1. Use the Lagrange error bound to show that this approximation differs from f of 1.1 by at most 0.01. Alright, so question C, we have the error bound formula. It's going to be less than or equal to absolute value of maximum of triple prime of s times s minus 1 q when s between 1 and 1.1 divided by 3 factorial, right? Which means we're gonna take the guys right here at triple prime c times s minus c power of 3 over 3 factorial right here, right? And this guy less than or equal to 60 right here, right? So we have 60 times s right here equals 1.1, right? So it's going to be 1.1 minus 1 power of 3 over 3 factorial. It's going to be 6, right? Now we're going to simplify this one. It's going to be 60 divided by 6, it could be 10, right? So we have 10 times 1.1 subtract 1, it could be 0.1 cube, right? So this guy turns out to be 0.1 square. It could be 0.01. So this one has been proved. Now let's move on to question D. Use the Euler method starting as s equals 1 with 2 steps of equal sign to approximate f of 1.4. Show the work that leads to your answer. Y over ds is going to be 3 minus s times y squared. So we copy over here. Find f of 1.4, right? Given the starting point is going to be s equals 1 with 2 step side, right? So we know that the step size from 1 to 1.4 and then 2 step size, so the step size should be h equals 0.2, right? And you have the formula y sub n plus 1 equals y sub n plus the step size times f prime of s sub n comma y sub n, right? Now you have the initial condition, it's going to be 1, negative 1 right here, right? 1, comma, negative 1, right? Now you scatter table. Now the initial condition 1, negative 1 when n equals 0, right? So this one is 1. This one is negative 1, right? Now when n equals 1, you have the step size 0.2. So this is going to be 1.2. Alright, so we need to calculate this one using the formula right here. y1 equals y0 plus the step size 0.2 times f prime of s0 y0, right? So it's going to be y0 is going to be negative 1, right? Right here. Plus 0.2 times derivative of this one as s equal 1, y equal negative 1. Substitute over here. So you have 3 minus 1 times negative 1 square, right? Now I'm going to simplify this one. It's going to be negative 1 plus 0.2 times 2 times 1, right? So it could be negative 0.2 6, right? So I have negative 0.6 right here, right? Now n equals 2, so have y2 equals y1 plus the step size 0.2 f prime of s1 commas y1, right? So it's going to be negative 0.6 plus 0.2. Now you substitute s1 y1 into this one right here, right? s1 y1 is going to be right here 1.2 and negative 0.6, right? So it could be times 3 minus 1.2, right? Times negative 0.6 square, right? So I'm going to simplify this one, negative 0.6 plus 3 minus 1.2 is going to be 1.8 times 0.2. So it could be 0.2 times 1.8 times negative 0.6 square. It could be 0.36, right? So y2 right here is negative 0.6 plus 0.2 times 1.8 times 0.36, right? Then S2 right here, which means 1.4, right? So answer should be this guy, and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand